Like Amazon, Boeing is delivering items around the clock to customers throughout the world. Logistics, it plays a pivotal role in Boeing's operations, and it is the main area of study for an industry and university research consortium known as CELDi.
CELDi is the Center for Excellence in Logistics and Distribution. We have been looking for a project that we could work with the University of Missouri on. The C-17 came up with a very compelling problem statement in terms of looking at large-scale network optimization.
We do a lot of shipping around the world now. We're global, and we see the opportunities to do our shipping smarter, either by using different modes of transportation, and are co-locating parts together and bringing them all back at one time so that we can reduce the cost of transportation.
Nothing happens without logistics. Everything moves. It has to move or you don't get anything. And so just being able to put together a plan that has a degree of complexity that we don't think about a lot of times. Stuff just shows up. But the reality is to get from point A to point B and have it timed right in the right quantities and at the right cost is a huge problem.
What we did was develop a program that they can use to minimize their transportation costs and look at every option, whether it be place a DC overseas or maybe reroute some of their shipments and look at the effect that has so that they can make the best choice that minimizes cost.
In some ways, these types of modeling and simulation tools are a little bit of a mindset shift for an organization like supply chain. It's really thinking about how we do all of our processes and how we can improve all of our processes.
This partnership provides another benefit, a doorway into Boeing for engineering talent.
It's really leveraging our university relationships to provide us with some leading edge technology. It also helps us to provide a pipeline to bring new talent into Boeing, which is all part of that innovation and growth strategy.
One of the reasons I went into industrial engineering was the large-scale network optimization problems, and for industrial engineering, that sort of problem is heaven for me. What excites me is it's all, there's so many moving parts, there's so many constraints, there's so many things that have to be optimized, and you have to pull all this data together and what looks like, huge Excel spreadsheets. You can solve that, break it down, analyze it, and save companies, millions of dollars.